Volume's about OX of these four problems then. The first one's y equals 2. So there's 2. From x equals 0 to 3. So when we rotate this line about the x-axis, we get a cylinder, don't we? Like so. And here's the slice, for example. The height is the y value, of course. That's the height of the function. The thickness is delta x. So the volume, as we've said above, is integral pi y squared dx, isn't it? Sum these cylinders from 0 to 3. So that's equal to pi then, take that outside. Integral of y squared, well y is 2, so it's 2 squared, so we can write 4, can't we? Dx from 0 to 3. Integrate 4, we get 4x. Between 0 to 3 is the bounds of the definite integral. So that gives us, top value is going to be 12, bottom value is going to be 0. So it just works out at 12 pi. Next one, y equals x plus 1. So let's have a look at that. Y equals x plus 1 is a straight line. Intercept 1, gradient 1. And we're going from 0 to 2. So from x equals 0 to x equals 2. Oops. So there's the height there. This line here is y equals x plus 1. And it's rotated about the x-axis. So here's a slice again, not very well drawn. Height y, thickness delta x. So the volume is the same again. Is pi y squared dx. And that goes between 0, x equals 0 to 2. Sum these cylinders up. Between 0 to 2. So that's equal to, bring the pi out the front of the integral, pi lots of 0 to 2, y squared, well that would be x plus 1 squared. So we could work that out separately, couldn't we? Let's just work it out here. When you have x plus 1 squared, it's just that times itself, which is a quadratic bracket. So it's x squared plus x plus another x is plus 2x, and then the last line is plus 1. So that's what we put in here. Now we can integrate. So let's integrate, raise the power by 1, divide by that number. Raise the power by 1, divide by that number. Constant integrates to constant times x between 0 and 2. Put the top value in, 2 in, put the bottom value in, 0. When you put the zeros in, they're all 0, so that will be 0. 2 in, 8, 2 cubed is 8, 8 over 3. Next value is 2 squared, which is 4, plus a 2. So thirds, this is 12 thirds, this is 6 thirds. So 12 and 6 is 18, and 8 is 26. So it's 26 over 3 pi, or 26 pi over 3. So what the answer is, if you type that in the calculator, you get this come out. So that's part 2. Y equals square root x from 0 to 4. So let's do that from 0 to 4. So we got here the square root function. When you square root 4, you get the height of 2 there, don't you? And then when you square root 0 there, you get 0. So that's those 2 points, and then you just generate this shape. And you get these discs. It's better. Height y, radius y, thickness delta x. As usual, the volume is integral pi r squared dx between 0 and 4, it said, didn't it? X equals 0 and 4. Y is equal to square root x. Square it then. Y squared is equal to x, isn't it? So we can replace that by, put the pi outside, integral x between 0 and 4 dx. So integrate x squared over 2, pi lots of, between 0 and 4. So we're going to get 4 squared is 16 over 2 is 8 is the top value. The bottom value is 0. So it works out at 8 lots of pi, which I can write in here. Okay, good. Now the next one, the last one. Y equals e to the x from x equals 0 to 1. We could get an online plotter to just plot this for us if we wanted. I'm just going to draw it. Y equals e to the x from x equals 0 to 1, wasn't it? There's the shape. So generated around the x-axis, it would generate shapes like this, a shape like this. Let's just check it again. Pi equals, there it is, from 0 to 1, y equals e to the x. Good. So the volume, integral between 0 and 1 of pi y squared dx. Now remember, y is equal to e to the x. So y squared is equal to e to the x squared. Power u times, so that's e to the 2x. So it's pi integral 0 to 1 e to the 2x dx. Now the integral of, it's a standard integral of e to the ax dx is equal to e to the ax over a plus k, standard integral, so let's use that formula. E to the ax over the value a, that's integrated then, between 0 and 1 is a definite integral. Pi, put 1 in, e to the, oh, ax, what's the value of a? Is 2, isn't it, in our case? Let's put 2 in for a, over 2. Put 1 in then, top value, e to the 2 over 2, e squared over 2, minus put 0 in, e to the 0 is 1, so you get half. So you end up with pi over 2, take the 2 out, and you get e squared minus 1. Okay, spare brackets there, don't need both brackets.